Hello guys, welcome to the course of TCP/IP. Today we will be discussing about the TCP timers. Okay, so now today's agenda is about the TCP timers. Before this video, what we have discussed the error control mechanism in TCP. So how that error control mechanism is going to be done and going to be accomplished that on the basis of the timers. So let's start. What are the different timers are available and what the timer it is. The very first, what we'll discuss the TCP timers. In the TCP uses the several timers to ensure that the excessive delay are not encountered during the communication. Because ultimate aim is toward the end-to-end communication, and end-to-end communication need to be happen in a very smooth manner, so that we have to maintain the timers at every stages. Okay, so that for that purpose, several timers are going to be. Each of the timers use the TCP, which reveal its role in ensuring that the properly it is properly sent from one connection to the another connection. So it is our TCP's duty that the end-to-end communication is properly done. So this is what the timer object. The TCP maintain multiple timers for each connection, every connection, because before sending the data, we have to establish the connection. And for every connection, TCP protocol maintain the multiple timers. Okay, the TCP couples error control and congestion control. That is, it assumes that the errors are caused by congestion, and obvious if there is a congestion, and definitely there will be an error. There will be an error. So here TCP uses four different timers mentioned below. So if you go with the timers, so timer number one is a retransmission timer, then persistent timer, keep alive timer, and time it timer. But apart from this also, we have some other timers are also available. Okay, we'll discuss one by one in this particular lecture. So let's take the very first is what the retransmission timer. What do you mean by retransmission? Very first, if the sender is sending data to the receiver, and if receiver is not receiving, let's say a negative acknowledgement is there, or maybe it is not confirmed that the receiver has received the data, it is going to be retransmitted. So what happened over here? Let's take to retransmit the lost segment, whatever the segments are lost, okay, are corrupted, or maybe some reason, the TCP uses retransmission timeout. That's RTO, retransmission timeout. Okay, when the TCP send a segment, the sender start and stop when acknowledgement is received. When TCP send a segment, the timer start. Okay, let's consider here is a sender and here is a receiver. It sends data. Okay, once it receives the acknowledgement, then it stops the retransmission. If the timer expire timeout occurs and the segment is retransmitted, if the timer expired, that is what which timeout timer occurs, then segment is going to be retransmitted. How it is going to be retransmitted, we'll discuss that out. Okay, then RTO, retransmission timeout is for what? One RTT, the round trip time. To calculate the retransmission timeout, we first need to calculate the RTT, that is round trip time. Okay, when the TCP send the segment in front of the sending queue, it start the timer. So again, for the better communication, at the queue level also it start the timer. When the time expire, TCP resend the first segment in front of the queue, then restart the timer again. Thirdly, when segment or the segments are cumulatively acknowledged, the segments are purged from the queue. Okay, then it is going to be deleted one by one. If the queue is empty, the TCP stop the timer. Otherwise, TCP restart the timers again. Okay, so at the starting of the queue, it start. Then again, first segment send, it starts. Then again, more than one sends, it start, and then it is one deleted again, it starts, and after that empty, it will again restart. Okay, so understand this one. What we have to discuss the cumulative acknowledgement. Before this video, what we have discussed the error control. There were retransmissions type was there, say cumulative and selective as was there. What happened in cumulative acknowledgement? Let's consider a sender and let's consider the receiver. Sender and receiver. Sender is sending some data. Sender is sending some segments. Okay, over here, let's say he has sent the four segment. Now here there is some time. There is some time. Within this time, all these four are received. All these four data segments are received. By combining it to acknowledgement, this particular sender, receiver sending single acknowledgement. Receiver sending is single acknowledgement, and this single acknowledgement is called as what? The cumulative acknowledgement. Sending the collective acknowledgement of all the received segments is called as what? The cumulative acknowledgement. Okay, so this is what very important. Apart from this cumulative acknowledgement, what we have to discuss? We have to discuss the acknowledgement timer. We have to discuss the acknowledgement time and timeout timer. What do you mean by timeout timer? So here let's consider the sender and let's consider the receiver. Sender sends the data. So if I draw this diagram, sender sends the data and set the timeout timer. So here somewhere timer is going to be set. After sending the segment, sender wait for some amount of time. It is called as timeout timer. So what do you mean by timeout timer? This is what the timeout timer. After sending the data, it waits for the some amount of time. If the receiver, if acknowledgement received within a time, if the acknowledgement received within a time, it is okay. It is okay. Within the TOT, it is okay. But if not received within a time, the retransmission is going to be done. Because if we if this acknowledgement if not within a received within time, it is okay, but this acknowledgement is received after a time, TOT time, then again the retransmission of the same packet will be done. So this is what the timeout timer, guys. I hope this is clear to you. Then what is the implication and significance of this timeout timer? Again, there is another timer. If the sender is sending to the receiver, then the receiver is receiving. So here acknowledgement timer is also going to be done. So what is acknowledgement timer? If it is too high, if it is too high, okay, let's rub this diagram and draw it again. Sender and receiver. Here sender and receiver. If sender is sending data, it is sending segments. Okay, if this acknowledgement timer is too high, okay, if acknowledgement time is too high, let's say sender is sending 1 2 3, and but receiver is not receiving, not giving any acknowledgement to this particular sender. So what is going to happen? Again the retransmission is going to happen. Again the retransmission is going to happen. And if it is too low, if it is too low, it is going to be its independent acknowledgement. So one sending, one acknowledgement, one sending, one acknowledgement. So it's supposed not to be high and supposed not to be low. It is somehow to be moderate kind of things. Okay. I hope that guide timeout timer and the ACK timer is okay with. Now there is a retransmission. We are focusing on the retransmission timers. What happened over here? The setting of the retransmission timer is crucial for the efficiency, because timeout timer is too small and timeout value is too large. What timeout? What we have discussed, sender and the receiver. If TOT is too small, okay, timeout value is too small, again the unnecessary retransmission can be happen. Unnecessary retransmission can be happen. If the timeout value is too large, the long waiting time before transmission can be issued. And implication or efficiency is depend upon what? Problem is that the delay in the network are not fixed, because network varies and topology changes. The delay is not fixed. Bandwidth is also not same. Every congestion can be there. Okay, so this retransmission timer must be adaptive. This retransmission timer must be adaptive. If you stick with the constant value, it is not good. We have to change it. It is going to be changed dynamically. Okay, so I hope guys this retransmission time is also clear to you. Now what happened with this retransmission time? Again we can say a sender and receiver is sending. If the retransmission timer is too small, okay, so by frequently it is sending, so unnecessary retransmission is going to be done. And if it is too big, if its TOT is too big, okay, that time also it is going to be a problematic concept. Now to understand the retransmission timers, what we have another timers, retransmission timers, types of the timers. Very first is a measured RTT, that is RTTM. It measured a round trip time for a segment is the time required for the segment to reach the destination and be acknowledged, although the acknowledgement may be include other segments. Okay, so in this case, this will be the piggybacking kind of concept. What the piggybacking? Sending an acknowledgement along with the higher level data is called what the piggybacking. Is called as what the piggybacking. So this is what the major RTT. Second will be smooth RTT. Second will be a smooth RTT. It is the weighted average of RTTM, that is measured average, weighted average of the RTTM. RTTM is likely to change and its fluctuation is so high that the single measurement cannot be used to calculate the RTO. Okay, we need to find how long it takes to send a segment and receive an acknowledgement for it. This is the measure RTT, that we need to remember that the segment and their acknowledgement do not have one-to-one relationship, but we can say the several segments may be acknowledgement together. So what the several segments may be acknowledged together is what the cumulative kind of acknowledgement. What the cumulative? I'm sending, let's say, 3 segments. Okay, I'm getting only one acknowledgement for all these segments. Is what the cumulative acknowledgement. And there is a third type, deviated RTT. The most implementation do not use RTT alone. So as RTT deviated is also calculated to find out the RTO. The measure RTT, that is RTTM, is likely to be changed for each round trip time, because what we have, the fluctuation is so high in today's internet, then the single measurement alone cannot be used for the retransmission timeout purpose. So here what we have discussed, the retransmission timer, and I hope the retransmission time, in order to understand retransmission time, what we have discussed: acknowledgement timer, timeout timer, cumulative acknowledgement, and all these things. Okay, then take about the second timer, and the second timer is what the persistent timer. Second timer is what the persistence time. Whatever the theory I have written over here, okay, to deal with the non-zero window size, the deadlock situation, the TCP uses the persistent timer. TCP uses the persistent timer. When the sending TCP received an acknowledgement within a window size of 0, it starts the persistent timer. When the persistent timer goes off, the sending TCP sends a special segment called a probe, and it response sent by the receiver to the probe segment gives the updated window size. What happened with this? If the updated window size is non-zero, it means the data can be sent now. And if the updated timer is still 0, the persistent timer is set again and the cycle repeats. So in order to understand the meaning of this, I will quote one scenario. Consider a sender and the receiver. Okay, a sender and the receiver. What happened? Before communicating this with the sender and receiver, what we have to do? We have to establish the connection first of all. We have to establish the connection, and we know that installation we required because we are using the TCP. What happened? Then only the data transmission can be happen. So here, connection establishment is done. Okay, once the connection establishment done, data transfer can be happen. Data transfer can be happen. Okay, but what happened? This is smooth. This is smooth operation. This is what a smooth operation. But sometime when the sender is sending data to the receiver, and receiver buffer is getting full. Receiver buffer is what now? Full. So it is obvious that the receiver cannot accept the data. Okay, so what the receiver will do? Receiver will advertise the message of his buffer size equal to 0, size equal to 0, and saying that I cannot accept no more segment from your side. Okay, so what then sender will react? Okay, again receiver what saying, if once I am getting free, that time I can receive this particular segment, but right now my window size is what? 0. Okay, it means what? I cannot accept the any kind of segments which is sending from your side. Okay, so it is better to stop, or it is better to slow down your rate. Then what? The sender never send the data. Okay, so sender never send the data. Then sender wait for a time. Sender wait for a time. So after receiving the window size 0, sender wait for particular time, and this is called as a persistent time, guys. So sender wait for the persist amount of time. It's called as the persistent amount of time. And what happen after that? Then it will send the probe message. Probe message what? 1 byte data message. And this will repeat and checking again if the receiver buffer is free or not. If receiver saying is again the receiver buffer is 0, so again the sender will wait for the persistent time. And once it is matched, then only receiver can accept. I hope that the persistent timer is okay with you. Okay, it is very clearly explained by me. Okay, thanks. Chalo. And now next is what? The keep alive timer. Keep alive timer. The third type of timer is what? The keep alive timer. Keep alive timer is used to prevent the long idle connection between two TCPs. Let's consider the client and the server, and we know the who is passive and who is active. Okay, very clearly, because we have discussed in the connection phase. If the client open the TCP connection to the server, the server transfers some data and becomes the silent, and the client will crash. Okay, if the client open TCP connection to the server, server transfers some data. If the client is live, the server can send the data. If it is silent, it means what server can guess that is what the crash. But in this case, the connection remain open forever because immediately server never disconnect this particular client. It's open forever. So keep alive timer is used. The keep alive timer is used. What happened with the keep alive timers? Each time server hear from the client is reset this timer, and the timeout time usually is 2 hours. Timeout timer is what usually of 2 hours. Okay, within 2 hours, what happened? If the server does not hear from the client after 2 hours, it send the probe segment. Server send the probe segment. If there is no response after 10 probes, consecutive 10 probes will be sent, each of with the 75-second apart. Within 75 seconds, 10 probe messages will be sent afterward 2 hours. It assumes that the client is down, then server can announce that client is down and that terminate the connection, and then the terminate the connection. What happened with this? When the server terminate the connection automatically, okay, when the TCP connection has been idle for a long time, the keep alive timer remind the station to check if the other side is still there. Okay, so ultimately, if the client and server is there, if the client have done their work first of all, and client, let's say, become the idle, that time server need to identify whether the client is live or not. For that purpose, server wait for the 2 hours. Within the 2 hours, what is going to do? What he sent? The 10 probe message will be sent within the 25 75 seconds apart. Okay, if no, there is no reply from the client side to the server, it then the server can announce that the client is dead now. Let's take a small scenario over here. Consider A as a server, B as a client. So what happened with the B is up and running. B is up and running smoothly. The B respond with acknowledgement. So B is responding. The client is acknowledgement. B has crashed and it's down. Let's say B has crashed and down. Then what happened? A will send the 10 more props, each of what 75 apart time. What I have spent. If A does not get the response, server net not if does not get the response, it will close the terminate connection. Okay. Then what happened with the B? B has rebooted. The B will send the reset segment, and B is up but unreachable, looks for the A, the same as with the second phase. So this is what the example of the keep alive timers. Okay, I hope guys it is okay with you keep alive timers. Then there is another timer used, that is what time wait timer. Is what the time wait timer. What happened with the time wait timer? This timer is used during the TCP connection termination. So TCP connection termination is what the third phase of the connection establishment. Okay, and in this timer starts after sending the last ACK for a second finalize, that is fin, and closing the connection. Whatever we have discussed in the TCP transition, that is first fin, second fin. Okay, the second fin and closing termination, it is going to be used. After the TCP connection is closed, it is possible for datagram that are still making their way through the network to attempt to access the closed ports. Okay, because the TCP is what the end-to-end process, end-to-end communication happens. The this timer is intended to prevent just closed port from reopening again quickly and receiving this last datagram. The value of time wait timer is usually set to twice to the TTL, the lifetime of the TCP segment. Now take the scenario how it is going to happen. Consider here sender and the receiver. Okay, in between this, what happened? The connection establishment is done. So both are connected, both are healthy conversions and healthy handshaking is done. Again, the data transfer is also done. Okay, but what happened? Last data also sent. Okay, sender is sending, let's say, these 5 segments, and fifth segment is also sent. Okay, then the receiver will send the acknowledgement. If no data to transfer by the sender, okay, they goes for the termination. If there is no data to send, they goes for the termination. But after sending the last acknowledgement, let's say the 5th one, we have to wait for some amount of time. We have to wait for the some amount of time, and that some amount of time is called as what? The time wait timer. So before, after sending the last segment, last data, the sender and receiver will wait for some amount of time. Generally, sender waits for the some amount of time is called as what? The time wait timer, because only he is not get that particular acknowledgement, or maybe some request maybe came from the other party. For that purpose, the time wait timer is going to be utilized. So okay, I hope guys all the timers are okay with you, and we have discussed the time wait timer, retransmission timer, persistent timer, keep alive timers, accumulative acknowledgement, and their other stuff also. I hope this is very important, guys, because there is a mathematical foundation available for it. And then for further videos, we are going to discuss the formulas of all these particular concepts. I hope the definitions are clear to you, specifically all the timers. And these timers are very important in terms of what the error control mechanism, error detection mechanism in the TCP. Okay, thank you. Thank you.